So at the beginning of, right before example 1, if you want to number these things and highlight this, these are the basic steps for sketching any rational graph. And we've done these already because we already graphed in section 2.3. But this sort of itemizes it. The first thing we always do is our non-permissible values. And our non-permissible values, they find either holes or vertical asymptotes. The second thing we look at is whether our graph is going to have horizontal asymptotes, oblique asymptotes, or none. Now here, I'm going to put the intercepts as number 3. That's the thing that we're going to do number 3. And we're going to add to this intercepts and other points, because sometimes it's not enough just to have our intercepts. Sometimes we can tell what the graph is going to look like by knowing what our intercepts are, but sometimes we need a few other points as well, so you can get those with a table of values. And finally, this step 4 is basically the step to graph. You're going to draw your graph towards your asymptotes. So they say here, what happens when you get near your asymptotes? What's your graph going to look like? Well, it's going to approach those asymptotes, and we're going to look and see how that works. So let's look at example 1. Sketch the graph. Step 0 is writing it in factored form. So the first thing you're going to do is you're going to factor. And on the top, this factors nicely to x minus 1, x minus 4. And the bottom is 1 minus x. Now you've seen this before, but can you see that we have an x minus 1 in the top of our fraction? And I have a 1 minus x on the bottom. I can factor a negative out of that 1 minus x to make it x minus 1. And the reason that's going to be important is because now these will simplify, and it will leave our equation, once it's simplified, as x minus 4 over negative 1. Is everybody okay that x minus 4 over negative 1 is the same as negative x plus 4? So number 1 was our non-permissible values. Do we have any non-permissible values? X can't equal 1. Again, we don't look at the simplified version to find our non-permissible values. We look at our original equation. And in our original equation, if you plug in 1 for x, you'll be dividing by 0. And so that is a non-permissible value. Is it going to be a hole, or is it going to be a vertical asymptote? It's going to be a hole, because that non-permissible value simplified away. So we're going to have a hole at 1 comma something. How do I know that it's at 1 comma 3? Yeah, once we've simplified it, you could plug 1 into that line. And you would get, when x is 1, y would be 3. And so that's going to be where that hole is going to occur. Now, once you've done your non-permissible values and your hole, what you're going to graph is your simplified version and add the hole to it. So now when we look at our simplified version, can you see that it's no longer a rational function? We can skip steps 2, 3, and 4 because you already know how to graph a line. How do I graph y equals negative x plus 4? Well, I know that it has a y-intercept of 4. I know that it has a slope of negative 1. I know that I'm supposed to make a hole at 1, 3. If you wanted to label your x-intercept, you could do that as well. When x is 4, y is 0. And so we just have a straight line with a hole. So we have 4 steps to do in these graphs. non-permissible values, oblique asymptotes, horizontal asymptotes, x-intercepts, y-intercepts, and then graphing towards the asymptotes. However, in this situation that it's simplified so nicely, once it's simplified, you say, hey, I know how to graph a line. That's straightforward. It's just a line with a hole in it. So what could be graphs that are similar to this? You know, your exam could have a line with a hole. You could have a parabola with a hole, right? If I had an x cubed graph and an x graph and something canceled, then I could have a parabola that has a hole in it. So you could have various graphs that have a hole in it. We're going to find out later, you can even have rational graphs with asymptotes with holes. No, you could have, you can make any graph you want, you could add holes to it. So a question for this one, and again, we are going to do all the examples today and then work on the questions, so it's question number 5.